Good morning. We're doing notes 5-7, interpreting information from graphs. So on example 1, it says a car dealership has 40 cars in stock. The auto manufacturer will deliver new cars to the dealership by car carrier. Each carrier holds 6 cars. Write a linear function that relates the number of carriers used to the total number of cars at the dealership. Graph the function that models the situation. And the first thing it wants you to do by yourself is define the variables. It'll always tell you kind of covertly what it's wanting you to write an equation about or your variables about. So if you look right here in this one, it says write a linear function that relates the number of carriers used to the total number of cars at the dealership. So generally when we do graphs, we use X and Y just so we know which axis they go on. A little hint, they usually tell you the X first and then the Y second. In some cases, they may mix it up. Kind of another little hint would be, if you see something's asking you about a total, then that's probably your Y variable. So I'm going to let the Y variable be the total number of cars at the dealership. And then on the X variable, it said the number of carriers used. So I'm going to use number of carriers used. And then it wants us to write an equation for that. I can see they already have 40 cars in stock, so that's like the given. So that's going to be our y-intercept. And then each carrier holds 6 cars. Anytime you see the word each, that's a pretty good indication of slope. So I know that the slope is going to be 6. So for my equation, I'm going to do y equals 6 cars per carrier. So I'm going to do 6 cars per carrier. Here's our carrier, which is X. And then the number of cars we already had was 40, so I'm going to put plus 40. Now, as you can see, 40 would be a huge number to put on here in the graph, so I can do what's called a break in the graph, where it's like, I'm going to break some of that off, and then I'm going to let the 40 start right here. And then after that, I can just count by ones all the way up. And on my x-axis, I'm going to count by ones as well. So my x-axis is the number of carriers used. And then the y-axis is the total cars. It's kind of hard to write all that in there. Okay, so I'm going to start at 40, and then I'm going to go up 6 over 1. So up 1, 2, 3, 4, 5, 6 over 1. 1, 2, 3, 4, 5, 6 over 1. And that's about as much as I can get on there. I'm going to intentionally not connect the dots on this one because anytime you connect dots, you're saying that the values between this dot and this dot are acceptable values, which really they're not, because here's 40. I'm sorry, here's 0 on the x-axis. This is at 0. And then on the y-axis, this is at 1. So I don't want to include numbers between 0 and 1. I don't want those decimals and fractions, so I'm not going to connect the dots here. So that's all that graph would look like. For number 2, it says a sporting goods store sells cans of tennis ball. There are 3 tennis balls in each can. The coach of the tennis team is buying supplies. Write a linear function that relates the number of cans to the total number of tennis balls and graph the function that models the situation. So here, it wants you to relate the number of cans to the total number of tennis balls. So I'm going to use X and Y again. And see the word total. I told you it'll be there a lot. Total number of tennis balls. So I'm going to put total tennis balls as my Y. And then the other variable it was wanting us to relate was the number of cans. So for my equation, I'm going to do y equals, for the slope, and really the only number that it gives us is this 3 right here. So I know it's 3 balls in each can, so 3 balls in each can, so that's my x. And it doesn't say they started with any, so I don't need to put a plus or minus with anything. So my x is the number of cans. And my y-axis is the total number of balls. So I'm going to start at 0 since it didn't say they previously started with any, and then my slope is 3, so I'm going to go up 1, 2, 3 over 1. 1, 2, 3 over 1, and I'm just going to keep doing that. And then once again, I got to think about, should I connect these dots or not? If I connect right here, I'm connecting between 0 and 1. And you want to think to yourself, do I want to have between 0 and 1 ball? Like, do I want to have half a can or something? So since I don't, I'm not going to connect these points. So I'll just leave it like that. On the next graph, it says students in a 9th grade class drew the following graph to represent how much money would be in the class fund after washing cars at a fundraiser. What does the slope and y-intercept of the graph mean for the given situation? So for the slope, I can see, let's see, it goes through that point right there. So I'm just going to pick 2 points where I can see it goes through exactly. So I'm going to pick those 2 points. So I got to think about my y values first, my change in y. So I'll start right here at 30, and then this one's at 40. So it goes up 10. And then it goes over 1, 2, 3. Let's see, hold on, I'm not sure I did that right. 2 to 6, so it goes over 4. So I went up $10 and I went over 4 cars. Which if I reduce that, I could reduce to 5 over 2 or $2.50 over 1. So what does the slope mean? The slope would mean like they're charging $2.50 per car for the slope. For the y-intercept, I can see it's right here at $25. So I could say the initial balance in the account was $25. For part B, it said if the graph had the same slope but a y-intercept of $15, what could you conclude about the fundraiser? I would say that they started with $15 instead of $25. And then on part C, it says if the graph had a slope of 5, what would you conclude about the fundraiser? So we could say that they charged $5 per car instead of $2.50. All right, and then the last one here, it says Sarah is driving to her grandmother's house who lives 10 miles away. She drives for 4 minutes and then notices that she is 5 miles away. What are the 2 ordered pairs that describe the situation? So when she starts, she's at home and 10 miles away. So I would say she's 0, time was 0, and she's 10 miles away. And then for the second one, I would say she drives for 4 minutes and she notices she's 5 miles away. So when time is 4, she's 5 miles away. And then it says write a linear equation from these 2 points. So since I don't have a graph handy, I'm just going to go ahead and do it on a table. So I've got 0, 10, and 4, 5. My change in y is down 5. My change in x is up 4, so change in y over change in x would be negative 5/4. So I'm going to do y equals negative 5/4 x, and then plus my y-intercept I can see is this one right here because there's no x value and only a y, so I'm going to do plus 10. So there's my linear equation. And it says, what is the total amount of time it takes her to reach the grandmother's house? So basically we would know that she had reached the grandmother's house when her distance away was 0. So I need to see when there's going to be a 0 right there. So you could plug it in or you could graph it either way. I'm going to just plug it in since I don't have a graph. So I would do 0 equals negative 5/4 x plus 10. So subtract 10 on each side. So I have negative 10 equals negative 5/4 x. And then I multiply by negative 4/5. So I would have x equals, that'd be 40 over 5, so that'd be 8. So my answer would be 8 minutes. And that's it.